intranet is a network within an organization, and communications on an intranet is a layered form of communication as well. Let's look at an overview of what we're going to cover. We're going to talk about how communications layers and their protocols are used on a network. Then we'll talk about the typical hardware components of a network. We'll also discuss several popular network technologies, and then how data is transmitted over several interconnected networks. So let's define networking first. Networking is a means of connecting computers together so that they can share data. That would be files and programs, and they can also share resources like printers and modems. And networking requires three components: a network interface card, client software, and a network protocol. When information is transferred through the network, it changes, and we use a model to define that communication. The model is called the OSI model. It was developed by the ISO, which is the International Standards Organization, in the 1980s. And OSI stands for Open Systems Interconnect. The OSI model is a 7-layer model of communications, and the layers are responsible for disassembling data into segments to be assigned to separate packets, and then later reassembling the packets into contiguous data. The model is also descriptive of passing packets to and receiving packets from the network media or the cabling. So let's look closer at the OSI model. At the top, where the user is, the application layer interfaces with the user or the application using the network. This is the top layer of the OSI model. Directly below this layer is the presentation layer, which compresses or decompresses data and interfaces with the application layer and the session layer. The session layer makes and manages a connection between two nodes on a network. So the session layer sets up the session. The transport layer verifies data and requests a resend when data is corrupted. The network layer is responsible for routing the packets, in other words, getting them to their correct destination, even if that's on another network. The data link layer disassembles packets and reassembles data into packets. And finally, the physical layer interfaces with the network media. The physical layer is responsible for putting the data on the wire. So data moves through each of these layers in order to be transmitted out onto the network, and then works its way back up through the layers in order for the user to be able to see the result. As data moves through the layers, it's in what we call packets or frames. And a data frame consists of a header, the data itself, and a trailer. Within the header is the data link header, the network header, the transport header, the session header, the presentation header, and the application header. The data itself is the largest part of a data frame. So this is not drawn to scale. If this was drawn to scale, the data portion would not be able to fit on this screen, and all the other parts of it could be the same size. So the data portion is actually much larger than this picture would indicate. So the overhead is not as large as this picture would indicate. The data is the major portion in a data frame. In the data trailer is a cyclic redundancy check, which is just like a checksum with modems. It's able to check to make sure that the packet was not damaged during transmission. Now, different technologies move data in very different ways. And we'll look at some different technologies in our next